So in the previous tutorial videos, we have covered quite much ingredients already for object-oriented programming in Java. So let me summarize very quickly for you by making some notes, and then we'll do the last kind of method, which is called Mutator. Let's also put it into context when we start summarizing in the beginning. Okay, let me move on to iPad over here. So this is what we have talked about so far. Whenever you're trying to declare a new class, you can have attributes. Okay, so in the case of the point, we got x and y. So they are simply just class level variables. So attributes are for you to characterize what an instance is like. Okay, for example, we are saying each point is going to be characterized by x and y being double values. Okay, and number two, we also got constructors. Basically, before you can try to manipulate the objects, you have to define constructor at least one typically. You can define multiple versions, but at least one. Constructors, for example, we got two versions for the point class. It can be x and y values, or it can be either along the y-axis or along the x-axis and some distance from the origin, right? That's what we talk about. And constructors are mainly for constructing new instances. So constructing new instances for your templates. Okay, in this case, the template we have that we're talking about is the point template. Okay, of course the templating can be depending on what problem you're trying to solve. Okay, and number three, we also talk about accessors. Okay, accessor, basically we have three accessors for you. Number one, you have to remember for each accessor, they must have a return type. Can be a string, can be a double, and also can be any type that we learned about before. Moreover, it can be any class name, as we'll see later. Okay, and also you want to give a name for the accessor. Okay, and also for the input parameter, it can be empty, or it can take as many input parameters as you like. Okay, we also talk about how you can trace this particular one with a point parameter. Okay, and what we're going to do, let me just say very quickly what accessor will generally do. It's simply going to asking questions, inquiring about the context objects. So we also talk about context objects in the previous video when we talk about accessor method. So for example, you might say p1.getDescription. You might also say p3.getDescription. So basically, when you say p1.getDescription, you're inquiring about p1. When you say p3.getDescription, you're inquiring about p3, about their x and y coordinates, right? For example. So now the last bits we're going to talk about for this video, so we have finished all the basics. So now for this last one, let me use in red. It's going to be about mutators. So far we haven't really talked about how you can change the values of the points. For example, if you have a two-dimensional plane like this, so far let's say I already created P1, let's say it's 3 and 4. Okay, I can only ask about what's the description for 3 and 4, and what's the distance from the origin, and what's the distance from maybe P1 until P2, for example, right? But I haven't really talked about how you can change the, for example, position of the point, which is very fundamental to do every time you want to move the objects along the two-dimensional plane. So that's something that's going to be handled by so-called mutators. Mutators simply means you're going to mutate the attributes for the context objects. Okay, so it's going to mutating the attributes of context objects, the attribute values of the context objects. Okay, so now the one I'm going to show you as an example would be, so now number one important detail for you to remember. The return type for mutator is also a method, so you always should return have a return type. But now for the return type for the mutator, it's just going to modify something without returning anything. So this is a keyword you have to put every time for mutator. It's going to be void. Void simply means return nothing. It doesn't return anything, but you gotta say it's void. On the other hand, for the accessors, because you put something that is not void as a return type, that means always you have a single return statements at the end of the body for each accessor method. Okay, and then we got a name for the mutator. Let's call move, and then we're gonna say character. It can be maybe U for up, D for down, L for left, and R for right. We're gonna see that. And then also by how much do you want to move. For example, I might say P1, the move. So you can see now P1 is a context object, the move, and then let's say move to the right by 3 units. Okay, so that means P1 is going to be now moving to the right over here to another new point. So this will be P1 again. Okay, so it's not going to be here anymore. So P1 is going to be to the right. So 3. Oh, sorry, it's going to be 6 and 4, just by 3, incrementing the x by 3 units. Okay, that's something we'll see. Okay, so these are the 4 ingredients you must know very well in order to complete the lab exercises for the rest of the semester. Okay, so now let's see how we can define the Mutator method in Eclipse, and then we're going to trace it in iPad. Okay, as usual. Every method call, either accessor method call or Mutator method call, the most important thing is to identify the context object, which is the object name besides the dot. Okay. Now let's go on to Eclipse over here. So I would say we have a new section over here. Okay, it's simply going to be called mutators. Mutators, modifying the attributes, values of the context objects, which is this, right? We talk about how to use the keyword this. Basically, this is simply going to be replaced by the context objects. If you say P1.move, the context object would be, the this would be P1. If you say P3.move, this would be P3, okay? So now when we define that, it's going to be void, okay? Void means returning nothing. And then we'll say move over here. And then we're going to give a character, let's say for direction. Okay, I'll just choose the name over here. Character direction, and also double for how many units. Okay, let's say how much do you want to move. Okay, and also here we have some assumptions over here. Let's say when we have L of assumptions on the direction value. L for left, R for right, and also we got U for up and D for down. Okay, so these are the 4 possible characters you can assume. Okay, let's do this one over here. So now we have to selectively, depending on what the value is for the direction, we're going to move that amount of units accordingly. Okay, let's say for example, if direction equals let's say up. Okay, if you want to move up, you want to increment the y value, right? You would say this dot y is assigned to this dot y plus the units. Okay, else if the direction is actually down, you're going to decrement the y, right? This dot y is assigned to this dot y minus the units. For simplicity, let's assume the units will always be not negative. Okay, we can also say else if the direction is simply just left. So that means we're going to move left. That means we got decrements the value for x. This dot x is assigned to this dot x minus the units. Okay, and because we assume these are the only 4 possible values for the direction, so now I can simply say else. So if I reach the else part, that simply means direction is simply to the right, right? In which case we're going to increment the value for x. So I can say this dot x is assigned to this dot x plus units. Again, let me remind you about whether using this is necessary over here. The answer is no, it's not really necessary, because you can see the name of the parameter direction and also units, they don't clash with any of the attributes we have in the current class, which is x and y. However, when we trace the code, because every occurrence of this is going to be replaced by the context object, which can be P1, P2, P3, or P4, it's easier for us to trace the code if you include this. Implicitly, if you simply say y, it's also going to work, because if you select y over here, you can see it's going to highlight all the way to line number 13, which is where y is declared as the attributes, right? That's something I want you to keep in mind. But I'm just going to use this, even though it's a little bit redundant, but I think it's going to pay off. Okay, that's the move I would like to do over here. So what I would like to do is to change the tester a little bit, and then to see the console output to confirm that it's working, and then we'll move on to the iPad to trace the code. Okay, let's go to point tester over here. Let me remind you what we did previously in the tester. Okay, you can see we actually got p1.getDescription versus p3.getDescription, calling the same method twice with a different context object p1 versus p3. Okay, so now let's say let me just save a little bit space for you over here. Okay, and then after this, we simply just say description of P1, P3, and etc. Right? Let me comment this out. I want to show you a slightly shorter notation over here. So this is this is the deal. If you actually store the return value from the accessor method call into a variable, that's good. So that means you can reuse the variable value. For example, description1 is used over here. Another way to do it would be you can simply include the accessor method call in place of this. That's also going to put it. Okay. So now, and let me tell you what the catch is. Okay. So now let's say this. I want to show you P1 only. Let's say P1 dot move. Okay. If I say P1 dot move, let's say move to the right by, let's say 3.2 units. Okay. And then I would say, let's say we have the 2 points in the context. P3 dot move over here. And then let's say move to the left. Let's say down. How about that? Move down by, let's say 4.7 units. Let's say that's what we have, P1 and P3. So these are mutated calls. Okay. So what we can say system. So we can say system.out.println. Okay. I would say after moving P1 and P3. Okay. And then after that, what I would like to do is to see what's going to be the output from all the accessor method calls. Compare this block of code, calling all these accessor method calls, compare with them before the mutated call and versus after this mutated call. Okay, that's what I would like to do. Okay, so now one way to do it would be, after this, you have to reassign all these variables over here. Let me show you approach number 1, and then I'll show you approach number 2. Okay, so now let's say these are the variables. Let me just give it one space over here. So that's one way to do it. Let me just put it here. Okay, I'm going to copy this block of code, and then I'm also going to paste to really emphasize they are simply identical. Except that since description number 1 is already declared, so you don't declare twice, you just reassign to that. So this is going to make sure this particular reassignment is going to make sure P1.getDescription is going to get the most up-to-date value for getDescription, as opposed to P1.getDescription over here is before the mutated call. Okay, so now I'm just going to show you this one as well. So now there are pros and cons. The cons for using a variable to capture the return value is you want to make sure you update the return value over here, as we said before in the previous tutorial in the elementary programming. If you actually don't do this reassignment over here, if you don't do this block of reassignments, description number 1 it will just be the same because it has not been overwritten by the latest call. Okay, so now this is one way to do it. Let me just show it to you, and then I'll show you a briefer way to do it, and then we'll trace that version instead. If I simply say this, okay, let's predict what's going to happen. How about that? Okay, if I try to do this, let's remind ourselves. So we got P1, which is going to be 3 and minus 4. Okay, let me draw that very quickly for you. Okay, this is our two-dimensional plane. Okay, let me draw a little bit better. And then 3 and minus 4. Okay, so this is P1. 3 and minus 4. Okay, and also we have P3, which is along the y-axis is going to be 0, 8. Okay, so along the y-axis over here is going to be P3. So P3 is going to be 0 and 8. Okay, that's P1 and P3 that we are creating. Okay, so now we want to see what's going to happen. Of course, if you just try to call these accessor call over here, we already traced it in the previous video. Okay, we're going to get exactly what you would get in the previous video. So now what we would like to do conceptually, we want to move P1 to the right by 3.2. Okay, so we want to move P1 to the right by 3.2. Okay, move P1 to the right by 3.2. Okay, let me make sure I did it right. Okay, move to the right by 3.2, which means after that, P1 is going to be, so that'll be 3 plus 3.2, 6.2, and then minus 4. So that's what we would expect to see when we try to say get description, P1 get description again, right? And similarly, we're going to say P3 dot move down by 4.7. So P3 dot move down, okay, it's going to be moved down by 4.7. It's going to be 8 minus 4.7, which will be 3.3, I think. Okay, it's going to be 0 and then 3.3. Okay, that's kind of the idea. So now when we try to print out get description again, when you say P1 dot get description versus P3 dot description, we're going to get these two console output instead. Okay, let's verify that. And then you can see similar reasoning for get origin and get also get distance from. So now if I go a little bit below over here, let's execute the code and see what happened. Okay, let me focus on the description. You can see this is after, that's a divider over here. Description of P1 is going to be 3 and minus 4. Okay, description for P3 is going to be 0 and 8, the blue one. So now after moving P1 and P3, so now for P1, 6.2 minus 4, 6.2 minus 4, the pink one, right? And also similarly for P3, it's going to be 0 and 3.3. 0 and 3.3. Okay, so we just confirm it's working. Okay, so now I will like, so this is only in the conceptual level, but now I would like to trace it together with you by seeing how exactly context objects and execution of the method is going to work for this particular mutated method quickly. For the simplicity of tracing, I would like to show you another way to write a tester quickly without using the variables over here. It's definitely going to work, but just for tracing, I can save a little bit of space. I just want to show you an alternative way of writing things in an equivalent way. Okay, so what I would like to do is I'm just going to let's say this. Can I just copy this line over here? Okay, just copy this block. And then I'm going to say control /, I'll turn everything into comments, which means you can definitely comment it back if you want to use this version. There's a typo over here. Okay, and now what I would like to do is I'm going to show you the second version that's going to work. Okay, let me just write it down for you. So this is version number 1 with variable storing return values of accessor method calls. Okay, and now for version number 2, okay, now for version number 2, print out accessor method call return values directly. In this case, we don't need the variables, so it can be a little bit shorter. Okay. Okay, let's see exactly how we can do that. Let me just paste the code that I just copied. What I would do is I'm going to say p1.getDescription is going to replace over here description number 1. Okay, and p3.getDescription is going to replace description number 2. And p1.get distance from the origin is going to replace distance number 1. And p3.getDistance from origin is going to replace distance number 2. Okay, and also p1.getDistance from p3 is going to replace distance number 3. Okay, so now I can completely get rid of these variables over here, just like that. Okay, so now what I will do is I don't so now I can just make a fresh call over here. So again, similar, p1.getDescription is going to replace this one over here. Okay, you can see, hopefully see what I'm doing here. I'm just trying to show you two versions that are completely the same, but second version is going to be a little bit briefer. Okay, replace this one here for distance number 1, and replace this one over here for distance number 2. And then once we move on to iPad for tracing, I'm going to highlight to you what you should really pay attention to. Okay, so now it's just going to be briefer, fewer lines of code to show. Okay, so that'll be version number 2. Okay, so now we move on to iPad for tracing version number 2. So now let's trace the code quickly on the iPad. So let me just say this. So this is already like a simplified version of your tester. I'm just going to do it for the accessor method called getDescription. And for how to trace the other two accessor methods, we already covered that in the previous tutorial. I'll just give you the insight into what if you try to make the same accessor method calls with a mutator method call in between. What's going to happen? That's the main thing I want to show you. And to really trace for other accessor method call in your tester, it will be the same. So you should really try to do those also if you're not comfortable with the concept. Right. So now let's see this. Let me focus on P1 to begin with. Okay. I want you to focus on, first of all, we have this particular line over here to create a new instance of type points, which is called P1. So this is what we are doing here, right? You can see P1 is now pointing to a new object over here. That's what we are doing for this one here. And then we have another line here. The first time we are trying to call the accessor method with P1 being the context object. We'll say P1.getDescription, okay? And then we're going to say P1.move. You can see all the pink lines so far, the context object is P1, okay? And also after this, we're going to say P1.getDescription, okay? Let me just remind you again. You can see over here, the context object is P1. The context object over here is also P1. The context object over here is also P1, right? P1 is the context object. But now also see this. If you compare this line over here versus this line over here, they are completely identical, okay? They're identical, however, P1.getDescription by calling twice is going to give you different result simply because there is an intermediate mutated method call which will modify the X or Y value for P1. Okay, that's something we want to find out. And then tracing the other one for P3 will be similar. Okay, let me just do this one at least to get yourself comfortable. Okay, so now we know that after this particular line over here, we're going to have P1 over here. P1 storing the address of this particular object. Again, it's indirect. And then when we say P1.getDescription, we're going to call this particular accessor method the first time, right, for P1. So now P1 is the context objects. So that means every occurrence of this is going to be P1, as we said before. And P1.x is going to look up the objects for P1, which is here, and .x will be 3, and P1.y is going to be -4. Okay, so that means the first time is going to give us 3 followed by -4. Okay, that's something we traced previously. Okay, so now let's see how the mutator method call can come into play. When we reach this line over here, where the context object is also P1, and then over here we say P1 is a context object, so we are calling this move method for the first time. And then we are passing this character value R. So that means every occurrence of direction is going to be replaced by the input R. Okay, every occurrence. So this will be R as well. And this will be R as well, and this will also be R. Of course, it's a single if statement. Only one of the branches will be satisfied. And also 3.2 is the second input value, the units, 3.2. Okay, so how do we execute this single if statement? R equals U is false, so we bypass. R equals D also is false, so we also bypass. R equals L is also false, so we also bypass this. So finally we get to the point, the else branch, the default case where it's R, in which case we'll simply say we just execute this .x is assigned to the units. And remember the context object now is really P1, so of course the this over here is simply referring to just P1. So what we are really doing is we say P1.x is reassigned to P1.x plus the units, which is 3.2. Okay, if we do this over here, you can see P1.x. Again, let's try to remember how we use a dot notation. So here, if you're only using P1 alone, this is the address. Okay, and the dot over here is about the lookup to locate the objects. So P1 is only the address over here, and the dot is really about this arrow over here that we are trying to look up the objects in the memory. And then when we say X is really talking about this X over here, so it's going to be 3, right? That's why we will actually get 3 over here. Okay, so 3 plus 3.2 is going to give us 6.2, and 6.2 is going to be reassigned to P1.x, which we know is this particular field. So which means we're going to replace this particular field by 6.2. So we are really modifying the context objects P1. Okay, or more precisely, we are modifying the objects over here that is being pointed to by P1. Okay, or we are modifying the object whose address is actually stored in P1. Okay, that's more precise. So after this, let's go on. So now after this, when we try to execute this line over here, where we are trying to, as I said before, this is simply identical to this one here. Are we going to return the same value for get description? The answer is no, because you can see 6.2 has now been the new value for x after this particular mutated method call. Let's see very quickly. So now we're going to call this particular method for the second time when the P1 is the context objects. So P1 is now over here. So P1 is again going to replace every occurrence of this by P1. So P1 here and P1 here. Okay. So now when we say P1.x is going to follow P1, the object that's being pointed to by P1, in this case, is going to be 6.2. So that means we're going to get 6.2, and then the y value remains unchanged, so it will be -4. Okay, so you can see that, first of all, you can see calling the same method with the same context objects for 2 times, first time and second time. They might give you a different result because there is an intermediate mutated method call on the same context object that is going to modify one of the or some of the attribute value that is going to determine the result. Okay, so you're going to see exactly this point over here. Okay, let me remind you about. Okay, I'll let you trace about p3.getDescription versus p3.description over here because we have some mutator change over here. It's going to be the same process. Okay, let's not spend time on this, but you should really try to exercise by yourself by tracing this if you're not comfortable. Okay, so now let me say one more thing. So now you can see that over here, if I try to compare 1 and 2 over here, basically the same method and also the same context objects, the result might be different if I have some intermediate mutated method call. Okay. On the other hand, if I try to compare, let's say this line over here versus this line over here, again, I'm calling the same method over here, but I'm having different context objects, right? It's P1 context object versus P3 being the context object. You can see there's nothing about mutator. Actually, talking about mutator between P1 and P3 wouldn't make sense because P1 and P3, they are different context objects. So now, even though I'm calling the same method, but because they are different context object over here, so the x and y values may be different. Okay, so now I really want you to know the following. Okay, whenever we are trying to make a method call, in general, it's just going to be some object name dot some method name. So this will be some objects. This will be some method. Of course, this is more precisely the context objects. Okay, you want to really know what the context object is and also which method is being called. Okay, you should always really draw the diagram like this to really help you trace. Okay, so now we have finished all the ingredients about object-oriented programming, and in the final video, the next video, I'm going to show you some application quickly.